Get this, a dying queen, a secret fortune, and a puzzle that she leaves behind in her will. Now, this isn't your typical inheritance story. Nope. This is a test of pure intellect left for her son. And you know what? We're gonna solve it right along with him.
So the story goes that when Queen Ratnamanjari passed away, she left her son Koisnam something way more interesting than just a kingdom. She left him a challenge. Tucked away in her will was a clue to a secret room, a room that was supposedly filled with an incredible collection of precious stones. But to get inside, he first had to solve her final, very clever puzzle.
And the setup sounds pretty simple on the surface. Just imagine a long hallway with 100 lockers, all lined up and closed shut. And then you've got 100 people, also lined up, just waiting for their instructions.
Okay, so how does this challenge actually play out? The Queen's instructions were very specific and, well, a little bit strange.
Here's the breakdown. Person number 1 walks down the line and opens every single locker, 1 through 100. Easy enough, right? But then person number 2 comes along. They only toggle every second locker, so they close locker 2, close locker 4, and so on. Then person 3 toggles every third locker. You see the pattern here? This just keeps going, all the way until person number 100 walks up to the 100th locker and toggles it one last time.
So this is the big question, the key to the whole thing. After all of that opening and closing, which of those 100 lockers will actually be left open at the very end? Because those are the ones that hold the secret.
Now you might be thinking it's just going to be a random mess of open and closed doors. But what actually happens is, well, something really beautiful. A perfect mathematical pattern emerges from all that chaos. These are the winners. The lockers left standing open are number 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Are you seeing it? Are you seeing the connection? These numbers are anything but random.
That's right. Every single locker that's left open is a perfect square, you know? 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, all the way up to 10 times 10, which is 100.
This must have been that big aha moment for Koisnam. But just knowing what the answer is, that's not the whole story. The real genius of this puzzle is figuring out the why. What is it about square numbers that makes them act so differently from every other number in this puzzle? Well, the secret, it lies in a little concept you probably remember from math class called factors. Yep, the entire key to cracking this code is all about how many factors each locker number has.
Let's just think it through for a second. A locker gets toggled by every person whose number is a factor of that locker's number. So for instance, locker number 12, it gets touched by person 1, person 2, person 3, person 4, person 6, and person 12. So the number of times it gets toggled is exactly equal to its number of factors.
And from there, the rule is incredibly simple. If a locker is touched an odd number of times, it's going to end up open. If it's touched an even number of times, it's going to end up right back where it started, closed.
This chart just lays it out perfectly. Take the number 6. Its factors are 1, 2, 3, and 6. That's 4 factors, an even number, so it ends up closed. But now look at number 9. Its factors are 1, 3, and 9. That's 3 factors, an odd number, which is why it stays open.
So why? Why does square numbers have this special property of an odd number of factors? Well, think about it. For most numbers, factors come in pairs. For the number 6, you have 1 times 6 and 2 times 3, nice pairs. But for a square number like 9, you've got 1 times 9 and then 3 times 3. That factor 3 is paired up with itself, so you only count it once. This is what gives all square numbers that unique odd count of factors. It's so cool.
All right, so Koisnam has cracked the first part of the code. He knows which lockers are open. But his mother had one final test of his intelligence. He still needed to figure out the passcode to get into that secret room.
The will had one final sentence. It said he needed to find the first 5 locker numbers that were touched, get this, exactly twice. Not once, not 3 times, but 2.
So let's think about that. Which numbers are these? If the number of touches equals the number of factors, then we're looking for numbers that have exactly 2 factors. What are those called?
And of course, that is the exact definition of a prime number, a number whose only factors are 1 and itself. The Queen's final clue was a clever little test of his knowledge of primes.
So the lockers that were touched only by person 1 and by their own corresponding number, well, they had to be these, the first 5 prime numbers out there.
And there it was. Khoisnam had the answer, and his mother's final puzzle was solved. The passcode to unlock that secret fortune was 2, 3, 5, 7, 11.
You know, the Queen's puzzle is so much more than just a smart riddle. It's this really beautiful example of how a process that looks totally chaotic on the surface can actually be governed by a simple, elegant rule from mathematics. It really makes you wonder, doesn't it? What other hidden patterns are out there, just waiting for us to find them in the world all around us?